All right, so let's go to day 2 of 6.6, and this is function operations and a little bit more. So we've done add and subtract, multiplying and dividing. That was what the last lesson was. And now we're going to do something that's a little bit trickier, but it's not too bad. It's called composition of functions. So whenever you're doing this, you are combining two functions. You're like putting one inside of another and then manipulating it from there. So there's a few different ways you can write it. Here is one way, right here, and you say, all of them are pronounced the same thing, f of g of x. So you can write it this way, you can write it this way, so f of g of x still. And then the other way that you'll probably see, I think, on the homework is, it's like the first way, except it has some parentheses. So f of g in parentheses of x. And yes, I know it looks like fog, but it's not. Another thing to note whenever you're doing these, it looks similar to the multiplication problems that we did on the last lesson, except for this time, last time the multiplication was closed dot. Whenever it is an open dot, you're going to be doing this composition of functions. Okay, so let's actually do some problems. I did change it from what was given, so I changed it to this. So if you don't have this on your paper, please write it down. So we have f of x, okay, equals 4 of x, and g of x equals 6x plus 2. So what you do on this is you take the second function, so g of x in this case, and you plug it in to the first. So I'm going to take all of this, the g of x, and plug it in to the f of x. Okay, doesn't sound too bad, right? Or maybe it does, I don't know. So this would be 4, right? And then we're going to put in for that x all of that other stuff, what the g of x actually is. So it looks like that. All I did was take that stuff from the g of x and plug it in for the x in the f of x. All right, now we need to clean it up. So I'm going to distribute that 4, so that gives me 24x plus 8. Can I solve it anymore? The answer is no, you cannot. So this is your answer. Okay, here's another one. So this time we're doing the f of x, so you're plugging in all of the, oops, that's not a highlighter, all of the f function into the g function. Okay, so you're plugging in all of this in for this x right here. Let's do it. So I have 6, sorry, I'm trying to get it together, times whatever the f of x function is. In this case, it's 4x. And then I have that plus 2. Okay, so that gives me 24x plus 12. And that's it. All right, next one, we have h of g. It's not hog. I know it looks like it, but it's not. Of n. So how you say it is h of g of n. I know it's weird. Okay, so this one's a little bit trickier, but not too bad. So you're doing the same thing. You're plugging in the second one into the first. So I'm putting all of this in for this variable right now here. And we have n's this time instead of x's, and they show that right here. No big deal. It's still a variable. You do the exact same thing. But this one is a little bit different. So when I plug that in, it's going to be the 3n minus 4. And since in the h of n, the whole thing is being raised to the second power, I need to raise that to the second power. Okay, so now that gives me, I'm ready to clean this up. Since this is a binomial, we're going to have to rewrite this as 3n minus 4 times 3n minus 4. And then bring down that plus 3. And the only reason I did that is because it's a binomial. I can't just square it straight up as we normally would. Okay, now let's go ahead and keep going. So we got to distribute this 3n. That would give me 9n squared. 3n times -4 is -12n. Now we're ready to distribute the -4, so that gives me -12n right there. -4 times -4 is +16. And then I'm going to drop down that +3 on the outside. Alrighty, now let's clean it up and write it in standard form. So I'm going to write my 9n squared first because that has the highest exponent. And then combine my n's. -12n minus 12n would give me -24n. And then my constants, +16 plus 3 gives me +19. And we did it. All right, let's do another one. So here we go. On this one, it is g of h of n. So g of h of n. So this time you're plugging in the h into the g. Okay, so plugging in this whole h into the g. So let's do it. We've got 3 times, and then we're going to write that whole h of n function, so n squared plus 3, and then you still have that -4 to bring down. All right, so now let's clean it up. I need to distribute this 3, so that would give me 3n squared plus 9 minus 4. Combine your like terms, and I have 3n squared plus 5. And that's it. 2 more. Okay, so this one's probably is as tricky as it's going to get. No big deal, we can do it. So I need to find f of g and g of f, so I'm going to do e first. So let's do f of g. So finding the g and plugging it into the f. So we're taking this and plugging it in for here, but you need to be careful on this one because there's 2 different places that they have a variable in f of t. Okay, so let's do it. I've got 2, so 2 times, and then I'm going to plug in that whole g thing, so 4t minus 8, and that t is being squared, and then plus 3 times the g of t again, so 4t minus 8. All right, now I have a lot to clean up on this. So go slow, take your time. I'm going to do the left side first. So 2, and then this is going to be 4t minus 8 times 4t minus 8, because that binomial is being squared. And then I'm going to work this out. So I'm going to FOIL before I distribute in this 2 right here. So let's FOIL first. So I've got 4t times 4t gives me 16t. 4t times -8 is -32t. -8 times -4t is -32t. -8 times -8 is +64. And don't forget, I still have that 2 on the outside, so I need to keep parentheses around it for now. All right, so we have some options. We can either distribute in that 2, or we can combine like terms. I'm going to choose to combine like terms first. It doesn't matter which way you choose, but that's what I'm doing. Ooh, I see I made a mistake. This right here, 16t, should be 16t squared, because it was 4t times 4t. You probably already caught that. All right, so now I still have my parentheses. So this would be 16t squared, dropping that down. Combine your like terms, that gives you -64t. And then drop down that 64. Now I believe I'm ready to distribute that 2 in. Okay, so 2 times 16t gives you 32t squared. 2 times -64t, that would be -128t. 2 times +64 is +128. Okay, that's kind of gross, but it's doable. You just got to go slow and take your time. All right, now let's do the left side. It's a lot easier, don't worry. So all I need to do is distribute this in, and then I'm going to bring it down to the bottom. So positive 3 times 4t gives you positive 12t. Positive 3 times negative 8 gives you negative 24. All right, now I have everything distributed. Now we just need to write it in standard form and clean it up. So I'm going to write the 32t squared first, because that's the first thing we need to do for standard form. Then I have my t's. I have negative 128t and a positive 12t. What would that be? Negative 116, I believe. Yeah. T. And then I have positive 28, or 128 and positive 128 and negative 24 would give me positive 104, I believe, if I did that math in my head correctly. Okay, that is it for that problem. So let's box it, and we're done. We just have one more to go. I think this one's a little bit easier, so don't worry. Okay, so this time we're plugging in the F into the G. So taking this whole F and plugging it in for that G. This one is definitely going to be easier. So I have 4 times 2t squared. Oops, I'm changing colors. I'm trying to be good with my color coding on this. So 2t squared plus 3t. And then I have a minus 8 that I need to drop down. All right, this one's a lot easier than the last one. We need to distribute this 4. So that would give me 8t squared plus 12t minus 8. Let's clean it up. Okay, look, there's nothing to combine, so there's no like terms that you can combine. It's also already in standard form. That was nice. So we're done. All right, that is it for this video. Thanks for watching, and have a great rest of your day. All right, so let's do day 3 of 6.6. This is all about word problems, so using these functions for real life situations. So here is the problem that we're going to be working with for this page. So Mrs. Roeder is in the market to buy some new Skechers. However, these shoes are unreasonably expensive, so she has set out to find some coupons and discount. Sorry, there's some typos on this. So she has found 2 deals. Deal 1 lets her take $80 off the purchase. Deal 2 lets her take 20% off her purchase. Okay, so number 1 says, let X represent the original price of the shoes. Use function notation to describe your cost. F of X using only deal 1. So we know how you do this is you're going to have F of X. That's where you start. So deal 1 is take $80 off the purchase. So how would you write that if you take $80 off the total? Well, that would be X, which is the price of the shoes, because it says that, minus $80. Okay, that's all they want you to do. Let X represent, number 2, let X represent the original price of the shoes. Use function notation to describe your cost, G of X, using only deal 2. So G of X is equal to, and there is a few different ways to write this. So you have X, which is the total amount, right? Minus, and if you're taking 20% off the purchase, so you have to figure out what 20% of the cost is. So you're going to do 0.2, or you could put 0.20. I'll put that. X. So this piece right here would be the 20% off, and this piece was the total of the shoes. Okay, so now we have our 2 functions. If the shoes are $300, which is the better deal for Mrs. Roeder to use? What if the shoes are $500? So they want you to figure out what would the price be both ways for $300 and $500. So let's do $300 first. I'm going to plug it into both equations. So whenever I do this, instead of f of x, I'm going to put f of 300. This is the mathematical way to write it. So that means that you are plugging in 300 into the equation. So f of 300 would be 300 minus 80, which would be 220. Okay. Let's do g of 300. So then that means we're plugging in 300 for the g and or the x and g of x. So that would be 300 minus 0.20 times 300. And stick that in your calculator and you end up getting 240. Okay, so there's two of the answers. Now we have two more to go. So they want you to do the exact same thing, but instead of 300, 500. So let's do f of 500. So this would be 500 minus 80, which would be $420. And then g of 500 would be 500 minus 0.20 times 500. And when you do that, stick it in your calculator, you get 400. All right, so let's go on to number 4. So form the composition of the functions f and g that would represent using deal 1 first and then deal 2. Okay, so if you remember, whenever you do composition of functions, they work backwards. So the second thing plugs into the first thing. So whenever you write this, they want deal 1 first, that's the f, and then deal 2. So I know this is backwards, it's a little confusing. So since you want the f of x to be first, you have to write the g first. So write it second. I know it's confusing. So it's going to be g of f of x. All right, they want us to actually do this. So this means that you are plugging in the f into the g. So this is going to be, let's do it like this. So that since the g of x is x minus 0.20 times x, it'd be x minus 80, that's your x. You can put parentheses around it. You don't really need to, but minus 0.20 times, and then you put the f of x in there, minus 80. Okay. So like I said, those first set of parentheses aren't doing anything, so I'm just going to drop them. This would be x minus 80. Let's go ahead and distribute this 0.20. So that would be negative 0.20x, and then plus, and it's plus because it's negative times a negative. Whenever you put that in your calculator, it gives you 16. Okay, let's go ahead and clean it up. So you can combine these two, x and then minus 0.20x. That gives you 0.8x. And then combine your constants. So negative 80 plus 16 would give you what, 64? Negative 64. And that is your composition of functions. So number 5, they want us to do the same thing except write deal 2 first, or use what it would be using deal 2 first. So we're going to have to do f of g of x, right? Because they want you to plug the second thing into the first. So let's work it out. The f of x is just x minus 80, so it'll be x minus 0.20x, and I will put parentheses around it, minus 80. Okay, Now, are the parentheses doing anything for us? The answer is no. So it's not doing anything for us. So all we need to do is combine like terms. So it looks like I can only combine my x's. So this would equal 0.8x minus 80. Okay, which compositions of functions is better if the original price of the shoes is 400? So how you do this is you plug it into both. So let's write it mathematically. I know it's weird, but it's good for you to get used to. So we'll do g of f of 400. Yep, I know that looks a little weird, but we're going to be plugging in 400 for the x in that equation. So that would be 0.8 times, I'm going to plug in 400 because that's what they want us to do, minus 64. Stick that in your calculator and you get 256. All right, now let's do the other one to see which one's the better deal. Let's do the f of g of 400. So this would be 0.8 times 400, because you're plugging that in there, minus 80. Okay, let's put it in your calculator, and you get 240. And so obviously the second way, this is the better method because you pay less in the long run. All right, that is it. Thanks for watching and have a great rest of your day. Recap on a few things about special right triangles. So I know we did this back in part 1, so it's been a while, a few months, but we just need to kind of refresh these properties because you will use these in this lesson. So let's first talk about the 45, 45, 90 triangle. So this is a triangle where it is an isosceles right triangle. So that means these two legs are the same. I'm going to call them x. And do you remember what the relationship was between the legs and the hypotenuse was? It was x times square root 2. Okay? So this is something that I would suggest writing on your cheat sheet because you can use it later. Okay, so now let's do one of these. So we're going to find out the other two missing sides. We know it's a 45, 45, 90. So these two are going to be the x, and this is going to be the x times the square root of 2. Okay, so this side over here must be 2 because they're the same, right? And so then for this, our x is 2. So then this hypotenuse must be 2 times square root 2. Okay, not too bad, right? Let's do another one. So now the hypotenuse is 5 square root 2. So I'm going to label them x times square root 2. So we're trying to figure out what the legs are. Well, how do we get from hypotenuse to the leg? Well, we're going to have to divide this to get it to just be x by the square root of 2. So I'll do it off to the side. Oops, that's a 2. So it'd be 5 square root 2 divided by 2. Divided by the square root of 2. Those cancel because we're trying to get that square root of 2 off of there. So this would just be 5. Right? That makes sense. If the x is 5, then the hypotenuse would be 5 times square root 2. Right, now here's the hardest level one. I don't know if you'll see very many of these in your homework and stuff today, but I'm going to do it anyway. So again, how do you get from the hypotenuse to the leg? So I'll label it so it helps a little bit. So how do you get from a hypotenuse to a leg? You divide that by the square root of 2. Okay, we need to get that square root of 2 out of the denominator because if you remember back to our rules, you cannot leave a square root in the denominator. How you do that is you multiply it by itself. And whatever you do to the bottom, you must do to the top. So then this would equal 7 square root 2 over square root of 2 times square root of 2 is just 2. All right, let's check. Can we reduce this? So when you're looking to see if you can reduce it, you look at the two non-square root numbers, because you can't reduce square root 2 and a regular number. Okay, so the answer is no, you can't reduce it. So this x is going to be equal to 7 square root 2 over 2. That's how you say it. I know it's a mouthful. And so is the other one. All right. Now, the next special right triangle was the 30, 60, 90. This one is also very useful. So on this ratio, if you don't remember, the shortest side is your x, always. So it's the side next to the 60-degree angle. The hypotenuse is 2 times the x, and then the other leg is x times the square root of 3. Okay, so it always basically how I do all these problems is I figure out what x is, and then I can find the other side. Okay, so here we go on our first problem. They give us the short side, so I'm going to rewrite my ratios. I think it's helpful. So this would be 2 times x. This would be x times square root 3. All right, this x is 3. Okay, so that's no big deal. The hypotenuse would be 2 times our x value, which we just said was 3, so 6. And then this leg would be our x, so 3 times square root 3. And you can't multiply those, so you just leave it just like that. All right, oops, I switched this around. Sorry, I'm going to change this to be, this 8 needs to be over here. I set this up wrong. Okay, so now we're ready. So it's going to be x, 2 times x times square root 3. So find out what x is. So if this hypotenuse is 8, and that's 2x, what would x be? That would be 4, right? You have to take it out, cut it in half. Okay, so now we have our x. So then this would be 4 times square root 3 over on that leg. Okay, this one I also need to change, sorry. So I meant to put that on the other side. This one's the last one we're going to do of these. So then this is x, 2 times x times square root 3. So then we're going to make this one 5. Oops, sorry. 5 square root 3. Okay, so let's figure out what the x is. If that's 5, or x square root 3 and 5 square root 3, then our x must equal 5, right? So then what would the hypotenuse be? It would be 2 times 5, which gives you 10. Okay, now that I wasted 6 minutes of your time, let's get in. All right, so before we actually get into 10.2, I want to do the actual lesson. Here it goes. So we have area of a trapezoid, rhombuses, and kites today. So a trapezoid, here is the formula. It's on your cheat sheet. It's 1/2 times your height, h is height, and then parentheses, base 1 plus base 2. So this is base 1 and this is base 2. Something to note is whenever you're doing these, your bases are always the parallel sides. Okay, sometimes it's hard to see them. So the B1 and B2 is always going to be the one set of parallel sides. Okay, so here's, okay, so how this is a trapezoid. All right, so we are going to write our formula so we get all our points. So area equals 1/2 times height, parentheses, base 1 plus base 2, close parentheses. Alrighty, so what would our height be? So our height on this one is 309. That's the distance between the two bases. So that's going to be 309, parentheses, Our bases are these two lines, the parallel sides. So that would be 205 plus 511. All right, go ahead and type that in your calculator just like that. Please type it in your calculator so you can practice. Pause the video if you need to. All right, so I just paused the video and typed it in my calculator, and I get 110,622. Sorry, I struggle with that number. So there's our third point with the correct answer, and your fourth point is your label, so miles squared. Alrighty, now this next problem, another trapezoid. It's not going to be quite as easy. Hold on, I'm going to pause this and erase some of that stuff. Okay, so what is the area of this trapezoid? They give us the two bases, right? We know this and we know this are the bases. Our problem is we need this distance right here because that is our height of this trapezoid. We need height for the formula. So, do you have any ideas of how to find the height? Let me give you a hint. So I'm going to draw a line right here. That's still the height, RQ. I just shifted it over. But if you notice, I have a 30, 60, 90 triangle. Weird. I just talked about 30, 60, 90s. So this is our 30. Okay. So I'm going to write the ratios to kind of help myself. So I know this is x, this is x, 2x, and this is x times the square root of 3, right? The other leg. Okay. Can I figure out what any of the sides are? The answer is yes, I can figure out what x is. So I know this side right here is going to be 2. And the reason I know that is because this whole thing right here on the top, SR, is 5. And the whole thing on the bottom is 7. So I got to do that 5 piece, which is right here, minus the whole piece, 7, and I get 2. Okay, so now I'm ready to do the rest of it. So this would be 2 times my x, which would be 2. So then that piece is 4. And then this other piece is 4 times the square root of 3. Okay, I believe I have all of the pieces I need. So I'm going to write my formula, 1/2 times height, parentheses, base 1 plus base 2. All right, if you notice, there is one number in here I do not need, and that is this 4. I didn't need to do that step. I did it just for fun, but really that's not the bases, that's not the height, so I don't need that for this problem. So here we go. I'm going to have 1/2 times my height, which is kind of weird, but it's okay. It's 4 times the square root of 3, parentheses, base 1 is 5, plus, what is base 2? Well, it's the original amount, the whole thing, so that would be 7. All right, so now you're going to type this in your calculator and round it to 1 decimal place. All right, and I just did it, and I got 41.6. Okay, and then let's get our label on there, meters squared. All right. So we're going to skip that, go to the next slide. We're talking about rhombuses and kites. So here is the formula for a rhombus and a kite. They have the same formula, which is convenient. So this is also on your cheat sheet right underneath the trapezoids. So it is 1/2 D1 times D2. Okay, D's. The D's on this are standing for diagonals. So D1 is this in the blue, D2 is in the red. And the order doesn't matter which one's D1, which one's D2, because we're going to be multiplying them, and in multiplication, the order does not matter. So let's just go on before I go to that. Let's go to kites. So, kites have the exact same notation, or the same formula, D1 times D2. So they have the same formula. All right, here's what to notice on rhombuses. So when you were doing rhombuses, the diagonals bisect each other. If you remember that from Unit 4 or Unit 5, I believe. So what that means is This piece and this piece, or that blue diagonal, is to cut into 2 equal pieces. And then the red diagonal is also cut into 2 equal pieces that are different from the 2 blue ones. But just remember that whenever you have diagonals of a rhombus, they're going to be cut into 2 equal pieces, and that's something you're going to have to use here in a bit. Okay, and then a kite. Here's our kite. And this obviously isn't cut into 2, both of these diagonals are not cut into equal pieces, but the short diagonal, the D1, this one is. So this piece and this piece are equal. You probably won't have to use that as much, but maybe. And then the long side of the kite is not obviously cut in half. Okay, so what is the area of the kite? KLMN. So we got our formula. Area equals 1/2 times D1 times D2. All right, I am going to make D1 be this amount right here. So what would that be? So I'm going to have 1/2 times, well, that is going to be 3 plus 3, so 6. And then I'm going to have D2 be this distance right here. And what would that be? Well, that's going to be 7. Okay, now let's do our formula. So 1/2 times 6 times 7, I believe, would be 21 meters squared. And that's it. Okay, this one's going to take a little bit more work, so stick with me. Please don't give up. Please write all this stuff down because you have some problems coming up like this in a little bit. Okay, a rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what is the area of the rhombus? Word problem, gross. We're going to have to draw a picture. Okay, so draw your best rhombus. Mine's going to look something like this. And so we know, since it's a rhombus, all 4 of the sides are going to be congruent. All right, so now let's draw the diagonals. Do a red and a blue like the notes did. Okay, so it's saying the longest diagonal, I'm going to call that the red one. That whole distance is 16. Okay, so and then the sides of the rhombus, the outside sides are 10. So this is 10, this is 10, all of these are 10. Okay, so if that whole red diagonal is 16, then half of it would be 8. Because it's cut into 2 equal pieces. All right, another thing you might remember about rhombuses is their diagonals are perpendicular, so they make right angles. All right, looky there, we have a right triangle. So we need to figure out, we're looking for what is this. Because we know that's half of that other diagonal, which is what we need. So we'll find that and then double it, and we'll have both of our diagonals and ready to do the formula. Okay, can we do, or which do we do? Or what do we use to find this formula, or this diagonal? Can we use 45, 45, 90s, 30, 60, 90s? The answer is no on both of them, and the reason why is because they don't tell us how many degrees those angles are. So we can't use that. So how do you find out a side of a right triangle if you have 2 of the sides? It's the good old faithful Pythagorean theorem. So a squared plus b squared equals c squared. Okay, which one must be our c? That's 10. And I'll make a be our missing side. So I have a squared plus, that would be 64, equals 100. So minus 64 minus 64. A squared would equal, that's 36. The last step is to take the square root of that. So a is 6. Cool. So this side right here is 6. Yes, I know we did all that work. 6 is not our answer. We're still trying to find the area. We just had to do work in order to find it. So we've got our formula. We're writing that. 1/2 D1 times D2. Okay, let's make D1 be the red diagonal. Well, how much is that red diagonal? It is 16, right? 8 plus 8. And then I will make D2 be the blue diagonal. How much is that? That's 6 plus 6, so 12. Okay, now when you do that math, you end up getting 96. Okay, and what is our label talking about in this problem? Centimeters squared. Okay, so that is that problem. Last one, the high occupancy vehicle HOV lane is marked by a series of diamonds. So this is in bigger cities. I've seen it in Dallas, Chicago, Las Vegas. So this is, it's on the interstates usually. And it's whenever you get into this lane, you have to usually have like 2 or more people in your car. You have to stay on it for a while. You can't change lanes and exit, and people usually move pretty quickly. The speed limit's a little higher usually. And it's supposed to help promote traffic and that stuff. But, all right. So anyway, long story short, this is a rhombus. Okay. What is the area of the HOV lane painted below? So we need the diagonals. So it looks like we have this right here is 2.5. So that means this is 2.5. And I'm sorry, this is hard to see on this drawing because this is so dark, but it is what it is. So I'm going to say this is 2.5, right? Because it is. So I know that diagonal, but the problem is I don't know the other diagonal. So we need to figure that out, and I think we can do it. So we need to figure out what this is. How am I going to have to do that? Well, since they don't tell us anything about the angles and how many degrees they are, our only option is Pythagorean theorem, exactly like the last one. So we have a squared plus, I'm going to make 2.5 be the b, equals 6.5 squared because that's your c. So a squared plus, I know that's 6.25. I got to put the other one in my calculator. 6.5 squared would give me 42.25. Okay, now let's subtract 6.25, subtract 6.25. So I have a squared equals 36, I believe. Square root. This is a coincidence. A is 6. They're not always 6. It's just coincidence on these last 2 problems. So that's 6. That must mean this is 6 as well. All right. That wasn't too bad. Now let's do our diagonals, or our formula. So we have 1/2 times d1 times d2. So 1/2, I'll have d1 be my yellow, the horizontal line. 2.5 plus 2.5 would give me 5. Times d2 is 6 plus 6, so 12. All right, and that gives you 30. And what's my label going to be? Feet squared. All right, that is it for this lesson. I'm sorry it was so long. Thanks for watching and have a great rest of your day.